Hi everyone, today let's look at combining some exponent laws. When multiple exponents are present within a single question, you'll need to consider BEDMAS to decide which operations you'll need to do first. In our first example, the second portion of the question has a power of a power. So the exponent law will tell us that we need to multiply those exponents. So we'll leave the first term, the -4 in brackets squared, and we'll multiply that by -4 to the power of 12. At this point, we can see that we have two powers that have the same bases, -4, and they're being multiplied. So the exponent law for this tells us that we're going to add the exponents. So 2 plus 12 will give us 14. So we'll be left with -4 to the power of 14. And we'll leave this written as a single power this way. When we have single powers with very big exponents, it doesn't make sense for us to expand it or evaluate it using our calculator because we'll have a really big number, and it'll make more sense to us to leave it as -4 to the power of 12 in this case. The second example will also require us to use BEDMAS. We will need to deal with the exponents first, which means that we'll deal with the power of the power at the end of the expression. So we'll leave the 6 to the power 3 times 6 to the power 5, and then we'll divide that by 6 to the power of 6. We're going to multiply those two exponents. When the power of a power is given, we know that implies multiplication. So the next step then is we are going to do the remaining operations from left to right as they occur. We know this because there is both multiplication and division that's still left to be done, and we know that that happens in the order that they occur from left to right. So 6 to the power 3 multiplied by 6 to the power 5, since they have the same base, we can keep the base the same and add those exponents. So we'll have 6 to the power of 8. We'll be dividing that by 6 to the power of 6. We know that the rule for dividing powers with the same base is that we can subtract the exponents. So 6 to the power 8 minus 6 will give us 6 to the power of 2. This one we can evaluate because 6 to the power 2 is the same thing as 6 times 6, or 36. Since it's a small number, it makes sense that we would evaluate it in this case. In our third example, in the numerator, we see that powers that have the same bases are being multiplied, so we can add the exponents. This will give us 3 to the power of 7 in the numerator, and we'll leave the denominator as 3 to the power of 4. In our next line, we will see that when powers have the same bases and they're being divided, we'll just subtract the exponents. So 3 to the power of 7 subtract 4 will give us 3 to the power of 3. And once again, because this is a small single power, 3 to the power of 3 is the same as 3 times 3 times 3, which is 27. So we can evaluate and leave our answer as 27. In the final example, the second term has a power that's being raised to a power. Because that base has a coefficient and a variable component, we're going to need to raise both parts of that to the power of 2. So we can rewrite this as 2 to the power of 2 and x to the power 6 raised to the power of 2. This will help us in our next step. So we'll leave the 4x to the power 6 alone, but we can change the 2 to the power 2 to being 4. And we know that when we have a power of a power, like this, the x to the power 6 all raised to the power of 2, that means multiplication will occur within the exponents. So we'll have x to the power of 12 there. Now we can simplify the expression by multiplying all of the whole numbers and multiplying the exponent pieces as well. When we multiply the whole numbers, we'll have 4 times 4, which will give us 16 as our overall coefficient. And when we multiply x to the power 6 with x to the power 12, we will know that since they have the same bases, we can add the exponents. So we will have x to the power of 6 plus 12, which will ultimately be x to the power of 18. So our final answer will be 16x to the power of 18.